Okay, another example in the book about finding relative extrema, in other words, relative maximums or minimums. But in this case, we're going to try to do it without actually graphing the function. Now, the great thing about these problems is if you want, of course you can graph the function, right? There's no problem with typing it into your calculator and seeing what the graph looks like. But we want to try to avoid that if we can. So the question here is, here's this function. Does it have any relative extrema? Does it have any relative maximums or minimums? Okay, well, how do we find that without graphing? Okay, well, first of all, we look at the derivative. Okay, the derivative of this function is going to be 4x cubed minus 32. The derivative of 4 is 0. Okay. Now, the first thing we need to do is find critical numbers for this function. Now, this function is never undefined, so it's only going to have a critical number when it's equal to 0. Okay, the derivative is never undefined. Of course, there's no division by 0, but it could be equal to 0. So if there are any solutions to this equation, we're going to get a critical number. Okay, so what about this equation? Well, it says 4x cubed minus 32 equals 0. To solve this equation, the book's pretty good about putting different equations, which may be difficult to solve by hand, but this one we can. Easiest thing to do would be add 32 to the other side. We get 4x cubed equals 32. Can divide both sides by 4. I get x cubed equals 8. So this equation is a nice equation, and x cubed equals 8. There's only one solution to this equation, and it's the cube root of 8. Okay, so one critical number, okay, x equals 2. Okay. Now the question is, when x is 2, do we have a maximum, do we have a minimum, or do we have neither? Okay. And what the book had said previously, and in the notes as well, that you can only have a relative maximum or a minimum at a critical number. Okay, so we only have one critical number for this function. That means this function has at most one maximum or minimum. Okay, but it could be that it has neither a maximum, relative maximum, or a relative minimum. So how do we find out? Well, actually, that's the good part. We can use a lot of what we just did in the last section. You see, if this is our one critical number, we can start, and again, I'll leave the derivative here because we're going to need that. But we can start asking ourselves the question, where does this function increase and where does this function increase and decrease? Well, the derivative tells us that. Okay, so here is the derivative. And just to make ourselves a note, it had a critical number when x was 2. Okay, just 1. Okay. So remember, we can look at these test intervals. Okay, there's only going to be 2 test intervals for the function being increasing or decreasing. From negative infinity to 2, it's going to be increasing or decreasing. And from 2 to infinity, it's going to be increasing or decreasing. Okay. So what we need to figure out is where is the derivative positive, where is it negative? Okay. What is it on each of these intervals? Well, let's think about this interval. Okay. Everything between negative infinity and 2. Well, the best number to pick in this interval is probably 0. Okay. F prime of 0 is just going to be negative 32, which is less than 0. Okay. That means that on this interval, f of x is decreasing. Okay, decreasing. Okay. Well, what about the next interval? Okay, we need a number bigger than 2 to put into the derivative, basically. Well, how about 3? Okay. So 4 times 3 cubed minus 32. Now, actually, you don't even have to compute that number as long as you know if it's positive or negative. Now, 4 times 3 cubed, well, 3 cubed is 27. 4 times that, it's going to be like 108. 108 minus 32, oh, it's some big number. Certainly bigger than 0, though. Okay. So on this interval, from 2 to infinity, the function, the original function, is increasing. Okay. Now that basically answers the question for us of what kind of point we have when x is 2. Okay. And in this case, we have a relative minimum. Okay. Why? Well, we just found out that our function decreases. Now remember, this is the original function. This function has a graph which is decreasing up until x is 2. So when x is 2, the function stops decreasing, and then it starts increasing. So it's decreasing to the left of 2, increasing to the right of 2. If the function is defined when x is 2, which it is, okay, it has to have a minimum there. Okay. So to the left, the function is decreasing. To the right, it's increasing. It has to have a minimum at 2. Okay. So what is exactly the relative minimum? We know there's going to be a relative minimum in this case. Well, it's going to be at the point 2 comma something. Now remember, this is not an interval. This is a point. We want to know the actual ordered pair where there's that relative minimum. Well, we know the critical number. We just need to find the y value, right? So what is f of 2? Okay, we're actually putting 2 into the original function because we want the y value that goes with x equal 2. Okay, so I take 2 to the 4th minus 32 times 2, okay, plus 4, okay, yeah, pretty big number here. Let's see, 16 will be 16 minus 64 plus 4. Let's see, negative 4. It should be like a negative 44. Okay. So at the point 2 comma negative 44, our function will have a relative minimum. Okay. Okay. So that's it. Now on this one, again, the great part about this section is that you can actually test any of these assertions you're making by looking at the graph. Very easy to graph this function. Again, just go y1 equals x to the 4th minus 32x plus 4. Type that into the equation editor. Now, since the minimum is so far down, the y-coordinate's negative 44, you will have to change the window. So after you type in the graph here, you might hit that window button. Okay. Now, as long as you're looking at x values a little bit to the left and right of 2, you'll be okay. But probably what I would do is go from that standard window, change y min to something like negative 50, y max, make it whatever you want. You can even make it positive 50. And then y SCL, y scale, make that like 10. Okay. So what this is going to do, it's going to show you 50 units on the positive y-axis, 50 units on the negative y-axis, and 10 units for each tick mark. Okay. So what you should see on this graph, you can already kind of tell, 1, 2, 3, 4, 5. Okay, right here when x is 2 and y is negative 44, which is going to be right about here, that should be a relative minimum on the graph. So probably the graph's going to do something like this, okay, but it should have a noticeable relative minimum on the graph right here. Okay. Now remember, changing the window is a very helpful thing on the graph. If you ever want to go back to that standard window on the calculator, hit the zoom button, and then 6, and that goes right back to the standard window.